Welcome to the fascinating world of Transit Signal Priority, or TSP. Picture this: a bus rolls up to a red light. It's as if it says, "Do you know who I am?" And voila, the light turns green. That's TSP for you. It's like a VIP pass for buses at traffic signals. This innovative tool is employed by transit agencies to enhance both speed and reliability. And let's face it, who doesn't appreciate a reliable bus, right? Now, there are two types of signal priority: passive and active. The passive kind is like that friend who always shows up on time. It doesn't react to individual vehicles. On the contrary, active is like your mum who always knows where you are. It sends a priority request as the bus approaches a signal. So buckle up as we dive deeper and explore the intriguing world of TSP and how it ties into the broader theme of dynamic transit fare pricing, mobility on demand, and the complexities of managing such systems. It's going to be a thrilling ride. Let's dive into the world of Bus Rapid Transit, or BRT, a game changer in public transportation. Imagine a bus system that operates as efficiently as a subway or a light rail. Sounds incredible, doesn't it? BRT is precisely that, a high-capacity, high-speed transit system that uses a variety of transit tactics. It's like the superhero of bus systems, combining the best of both worlds, the flexibility of buses and the speed and reliability of rail. Key features of BRT that set it apart are dedicated lanes, off-board fare collection, level boarding and intersection treatments. These elements together make BRT a rapid, efficient and user-friendly transit system. But what makes BRT a real game-changer are the various techniques that can expedite its operations. Prepaid fares, limited stops, easy boarding and the use of intelligent transportation systems technologies are just a few tricks up its sleeve. BRT is not confined to large urban areas. It's making its mark in suburban areas, medium-sized cities, and even a rural transit district. But remember, successful BRT implementation requires careful planning and design. It's like fitting a puzzle piece perfectly into the existing infrastructure. So BRT is more than just a transit system. It's a revolution in public transportation, offering a flexible, efficient and inclusive transit system that caters to the needs of all users. Next, we'll explore how dynamic transit fare pricing plays into this system. Stay tuned! Dynamic transit fare pricing denotes a scenario where transit fares are swayed by real-time factors like bus congestion. This avant-garde strategy is gaining momentum as it's seen as a potent mechanism to navigate troublesome congestion issues. Essentially, the expense of using public transport like buses and trains oscillates based on their occupancy at a specific moment. This dynamic pricing trend is not confined to the transportation realm. Various sectors, including hospitality and retail, are employing it to harmonize demand and supply effectively. The core concept propelling this pricing model is the belief that price should mirror scarcity. Consequently, during peak hours when seat demand shoots up, fare prices would generally escalate. Conversely, in non-peak times when demand is lesser, fares are likely to decrease. At present, municipalities and public transit agencies implement diverse fare policies. Some have fixed-rate fares, others utilize zoned fare systems. However, a novel trend is surfacing dubbed variable transit fare pricing. Here, the fare fluctuates based on the time of day, the day of the week, or trip length. Yet other than these variables, the fare remains steady. The principal goal behind dynamic pricing is to strike a balance between supply and demand across various transport modes. By embracing such a model, it is feasible to optimize the entire transportation network, ensuring efficiency and effectiveness. Next, we move to Mobility on Demand, or MOD. MOD is a network of efficient, affordable and universally available transportation options. It introduces mobility as a service, a system that combines various transport services into one accessible platform. This includes public transportation, ride-sharing, bike-sharing and on-demand shuttles. On-demand transit, a MOD feature, appears in two versions: partially scheduled service, operating along a preset route with scheduled stops, and fully on-demand service with no fixed routes. We'll spotlight on traditional on-demand transit modes, such as paratransit and dial-a-ride services. These examples will give us a better understanding of dynamic transit fare pricing. Stay tuned as we delve deeper into this complex yet fascinating world of modern transit solutions. As the landscape of mobility options has expanded in recent years, the ability to effectively coordinate and manage these various options has become far more intricate, demanding a higher level of organization. With the rise in transportation options like public transit, ride-sharing, electric scooters, bikes, and automated vehicles, managing these systems has become a challenging task. A recent modeling study vividly demonstrated this complexity. It focused on the difficult task of balancing supply and demand across diverse mobility options, such as general-purpose lanes, tolling systems, and rail transportation. The study showcases rising complexity in managing modern transportation systems. The results point to the multifaceted nature of this task, stressing the need for a comprehensive approach. The transportation profession agrees that deliberate and strategic measures are crucial. It's essential to maximize the benefits of shared services that modern transportation systems offer, while minimizing potential negative impacts. Acknowledging these challenges has triggered a renewed emphasis on innovative solutions for managing these complex systems, ensuring the benefits outweigh the potential downsides. Another consideration for this type of fair pricing is whether customers who cannot afford the latest technologies or have difficulties adopting and using new technologies can equitably benefit. Dynamic fair pricing, while innovative, could pose challenges due to the varying financial capabilities and know-how of consumers. The technology used must be affordable and user-friendly to ensure universal benefit. It's critical to provide real-time or near real-time information to commuters, and this could cover details of pricing. Equally important are smartphone applications that simplify the coordination and payment for travel. These applications would ideally facilitate the arrangement and payment for the use of multiple transportation modes in a single trip. Also, coordination among public sector services should be increased to ensure a streamlined journey for all. These considerations, while not exhaustive, are crucial for understanding the potential challenges and strategies for implementing dynamic transit fare pricing. Finally, despite the challenges, dynamic transit fare pricing can benefit from specific considerations and approaches. Furthermore, we move into the complexities of dynamic transit fare pricing. It's vital to underscore the importance of transparent dialogues in pricing strategies. It bolsters trust among commuters and ensures fair system use. Safeguarding user privacy, since dynamic pricing requires data on travel patterns, is crucial. Robust protection systems are therefore essential. Communication is key. By informing the public about the reasoning and methods behind price changes, we foster comprehension and understanding. Factoring in support services like parking can impact a traveler's transport choice, affecting demand. Consideration of these elements is critical for successful implementation. As we progress, our systems must be not only efficient and adaptable, but also transparent, communicative, and privacy conscious. We now turn to an aspect that is often overlooked: enhancing connectivity and accessibility. This has particular significance in low-density regions and for those with disabilities. The key to this is the first-mile, last-mile connections to regional transit services. Services maintain efficiency via dispatchers, computer-aided dispatch, and automatic vehicle location technology. Yearly checks ensure these methods' proficiency. Success hinges on supportive policies like a prompt pickup window policy, eligibility checks, and rider training. Further strategies include local bus services, rapid transit, fare strategies, and land use planning. These additional practices enrich the fundamental approach, rendering dynamic transit fare pricing more than just a pricing model. It's a holistic approach that, when implemented correctly, can significantly enhance the connectivity and accessibility of our transit systems. As we continue, we find ourselves on the topic of cost versus benefit analysis. It is essential to understand the costs and benefits associated with its implementation. Key costs include operation of extra services like paratransit, which are costly but invaluable for those with limited mobility. Costs like staff wages, vehicle upkeep, and insurance are considerable. The benefits of multimodal transport centres are significant. They optimize travel time, provide seamless connections, and boost local economy. Another crucial aspect is data collection. Despite being expensive and tedious, it enables demand pattern insight, route optimization, and fair pricing setting. It's a strategic investment. The implementation of these measures, though complex, can have various benefits. With careful planning and execution, it can lead to a more flexible, efficient, and inclusive transit system that caters to the needs of all users. As we delve further into the realm of transportation, we turn to multimodal transportation centers in urban locales and major junctions. Their success depends on the coordination of all transportation services and businesses. Regular analysis helps adapt to public needs and future planning. Policies foster a dense mix of uses around these centers, incorporating transit-oriented development and smart concepts. Centers ideally locate in employment sectors and cultural districts. They cater to a diverse range of users, with on-site retail and services meeting commuter needs and enhancing the center's appeal. In conclusion, planning and implementation of multimodal transportation centers require careful consideration of various factors and strategic among different stakeholders. These centers can significantly enhance the accessibility efficiency of public transit, making it more appealing to a broad range of users. Having understood these best practices and key considerations, let's delve deeper into site analysis and successful implementations. Determining a site for such a center involves factors like access to transit lines, zoning restrictions, and security. Notable examples include Denver's Union Station and Anaheim's world-class Arctic Hub. Challenges in implementation exist, including managing circulation and financing. Despite these challenges, the benefits in terms of connectivity and efficiency are undeniable. They are a crucial component of dynamic transit fare pricing, and with careful planning and coordination can significantly enhance the public transit experience. As we move forward on our journey, let's take a deeper look at the project timeframe, cost, and data needs. Building a transportation center is extensive, with the timeline depending on the project scale. Planning begins well before construction, requiring public engagement. Costs can vary greatly, primarily based on the project's size. If the center includes commercial spaces, these revenues can offset part of the long-term operational costs are significant, and funding agreements may be necessary. Funding can come from government, toll revenues, private sector, and fares. Data is crucial for planning and operating these centers. Transit availability, parking, and lane closures require real-time info. Demographic data, land use data, and transportation network data are vital. By understanding these aspects of project timeframe, cost, and data needs, we can better plan and implement successful multimodal transportation centers, enhancing the public transit experience and making our cities more connected and accessible.